Assalamu alaikum students. So this is the time value of money video lecture series part 6. Hopefully this is the last lecture. Right. So today we will solve question number 27. So what we have in question number 27? In question number 27 it says that Mr. Harun is comparing following two offers to support his daughter's education in USA. Right. So first offer is insurance offer. So this one is insurance offer. So what insurance company is saying that if you deposit 1 lakh taka, that is 100,000 taka per month now for the next 10 years, then you will receive 350,000, that means 350,000 taka per month for the following 10 years after the deposit. So this is the insurance offer. That means if Mr. Harun deposit 1 lakh taka, that is 100,000 taka per month now for the next 10 years, then you will get, that means if Mr. Harun deposit 1 lakh taka per month from now for the next 10 years, so then he will receive 350,000 taka per month for the following 10 years. So this is the insurance company is saying that. So insurance company is saying like that, right? So let me put it in the time diagram. Let me put it in the time diagram. So the insurance company is saying that insurance offer. So what insurance company is saying? So today is period 0. That means if Mr. Harun deposit 1 lakh taka after 1 month, 1 lakh taka after 2 months, and like that way up to 10 years. Up to 10 years. That means up to 10 years. So 10 years means in 1 year we have in 1 year we have 12 months. So in 10 year we will gonna have total 120 periods or 120 installment or 120 payments of 1 lakh taka each. So if Mr. Harun pay 1 lakh taka at the end of every month and like that way up to 10 years, in that case he will get 350,000 taka for the following 10 years. So this is annuity. Consider it like annuity 1. So let us consider it like annuity 1, and another annuity will start from here to here. So this is again for 10 years. This is again for 10 years. That means 120 months or 120 payments. So 120 payments, right? So again a second annuity will start from here. So period, so that means after 10 years a second annuity will start. So that means if Mr. Harun deposits 1 lakh taka at the end of every month and like that way up to 10 years, so that means total 120 installment. In that case insurance company will after that insurance company will pay him, insurance company will again pay him total 120 installment of 350,000 taka each for the following 10 years. So let us consider it like annuity 2. So annuity 2, right? So this is insurance offer. Now let's check out the next offer. So what the next offer is saying, right? The next offer is saying the bank offer. So bank is saying that if Mr. Harun opens a monthly deposit savings account for the next 10 years, then he will receive a flat 20%, so flat 12% interest compounded monthly from now to next 20 years period. right? So that means bank is not saying you that how much installment you should pay or how much you will receive in future. Bank is not saying anything like that. So bank is just saying that if you open a monthly deposit savings account for the next 10 years, then you will receive a flat 12% interest compounded monthly from now to next 20 years period, right? So this is the interest, right? So Mr. Harun is confused. Can you help him choose the best offer? So can you help him choose the best offer? So can you help him choose the best offer, right? So let's do it. So that means, so if you want to compare the insurance offer with the bank offer, if you want to compare the insurance offer with the bank offer, you need to consider that so that means if you want to compare insurance offer with the bank offer, in that case we will also consider that Mr. Harun will deposit same 1 lakh taka at the end of every month. So we will consider that Mr. Harun will save same 100,000 taka at the end of every month up to 10 years period. The total 120 payments, and we will find out that in that case, if he saves like that up to 10 years, then how much bank will give him for the next 10 years, right? So that means, so if you want to compare it with the bank offer, so what we need to do, we need to consider that. So to compare it with bank, so to compare it with bank, so let us consider that Mr. Harun will deposit same 1 lakh taka. Like the insurance company, Mr. Harun will also pay same 1 lakh taka to bank at the end of every month up to 10 years period, that is 120 months. So that is 120 months. So that means up to 10 years, is equal to 120 payments. So this is annuity. Let us consider that this is annuity. This is annuity 1. Let us consider that this is annuity 1. So to compare that, so that means like the insurance company, here also we will deposit same 1 lakh taka at the end of every month, and like that way up to 10 years, that is 120 payments. So we need to find out that how much bank will give us for the next 10 year period. So that means how much bank will, that means second annuity. So second annuity for 10 years. So same like the insurance company, we need to find out that so same like the insurance company, we need to find out that, so how much bank will give us, for the next 10 years, for the following 10 years. So how much bank will give us for the following 10 years. So that means here the insurance company will give us for the following 10 years, insurance company will give us 350,000 taka at the end of every month. So we already know it. Insurance company specifically told you that they will give you 350,000 taka for the following 10 years at the end of every month. But bank, we need to find out that how much bank will give us if we save same 1 lakh taka, same 100,000 taka at the end of every month for next 10 years period. So up to this is same for insurance and bank. So up to this is same for insurance and bank. So now we need to find out that how much we will get. That means we need to find out the value of C to compare that how much bank will give us and how much insurance company is offering us. So we need to find out the value of C for this, right? So to find out the value of C, what we need to do, so to find out the value of C, we need to do, so for example, so I'm drawing the diagram again to give you a precise or clear understanding. So up to 10 years you are depositing. So today is period 0 obviously. So after 1 month you will deposit 1 lakh taka, 100,000 taka. After 2 months you will deposit again 100,000 taka, and like that way total 120 payments. So first of all we need to find out that how much you will be able to save, how much. So we will be able to save by making this payment. So that means we need to find out what will be the account balance. That means up from this 10 years saving, how much you will get after 10 years. So that means we need to first find out what will be the future value. So first of all we need to find out what will be the future value here. That means how much we will be accumulate, from this 10 years savings, right? So first of all let us find out this one. So that means after 10 years what will be, how much money will be there in our account from this 10 years savings. So let us find out this one. So future value of annuity, we want to find out the future value of annuity. So future value of annuity, that means C, future value of annuity formula is C divided by R multiplied by 1 plus R power T minus 1. Right. So C, here the monthly installments are 100,000 each, 1 lakh taka. Interest rate. So interest rate, it said that 12% interest rate. So 12% interest rate. So 12%, right. So 12% interest rate. So interest rate is 12%, sorry, interest rate is 12% compounded monthly. Interest rate is, so bank will give you flat 12% interest compounded monthly for the next 20 years period, right? So flat 20%, so flat 12% interest compounded monthly. So that's the interest rate. So 12% means 12% compounded monthly. So 12% means 0.12 divided by 0.12 is the 12%, means 0.12. Compounded monthly means we need to divide it by 12 to get the monthly rate, right? So 1 plus 0.12 divided by 12 power T. So we are making total 120 payments. So total 120 months. So in 10 years we will have total 120 months minus 1. Right, so let us calculate. Let's see what we will get. Let's see. So the answer will be, so after we calculate, the answer will be 2300 38 68 2300 3868.9457 taka, 9457 taka, that means taka. So that means 2 crore 23 million actually, 2 crore and then 3 million, 2 crore 3 million 3,868 taka, right? So this is what we will get. So these will be our total savings after 10 years. So this is the amount that we will get after 10 years, right? Now the second annuity, we need to solve the second annuity now. So second annuity. So second annuity will start from here. So this is the point where the first annuity ends, and this is the point where the second annuity will start. This is the point where the second annuity will start. We need to now find out. So this is the second annuity. This is the second annuity. Again for 10 years. This is the second annuity again for 10 years. This is the second annuity again for 10 years. So this is annuity 2. Right. So we need to find out how much you will get at the end of each period. How much you will get at the end of each period up to 10 years. That is 120 payments. Right. So obviously, if you want to get some money at the end of every month, you must make a lump sum amount of deposit in the bank, and this is the deposit that you will make at this period. So that means after 10 years of depositing, so that means after 10 years of depositing 100,000 taka at the end of every month, so you have already deposited 100,000 taka at the end of every month up to 10 years, and after 10 years this is the amount that you accumulated. So this is the amount that you have accumulated. So which means this is the amount you have accumulated. So your accumulated amount is this one. So that means after 10 years you have this much amount of money in your account. So since if you deposit this much amount of money after 10 years in your account, so in that case bank will give you a certain amount of cash flow. Bank will give you C amount of cash flow at the end of every month up to 10 years, right? So that means for these annuity, this is the present value. So for these annuity, this is the present value. This amount is the present value, right? So for these, so let me draw it again. So let me draw it again. Right. So let me draw the graph again. So first of all, this is annuity 1. This is annuity 1. At the end of every month, you have deposited 1 lakh taka. At the end of every month, you have deposited 1 lakh taka, and up to 120 payments. 10 years means 120 payments. And by doing that you have accumulated. By doing that you have accumulated this much amount of money. So by doing that, you have accumulated this much amount of money after 10 years. So from there, a second annuity will start. From there, right? So if you have this much amount of money in the bank account after 10 years, in that case, bank will give you C amount of cash flow at the end of every month, for the following 10 years. So that means bank will give you these a C amount of cash flow at the end of every month for the following 10 years. So following 10 years means 120 payments, right? So which means this is annuity 2. So which means that is the for these annuity, this is the present value. So for these annuity, this is the present value, right? So that means present value of annuity we know. So So we need to use now present value of annuity formula. So present value of annuity formula is this one, 1 minus here 1 plus r power minus t. So we already know the value of p, we need to find out the value of c now, right? So we already know that to find out the value of c, we can do cross multiplication. So the present value of annuity, so that means after 10 years, we have this amount of money in the account. So since we have this amount of money in the account, bank will give us C amount of cash flow for the following 10 years at the end of every month, right? So that means for this annuity, this is the present value. So this is the present value for that annuity. So the present value is 230038 68 .9457 multiplied by R. So R is what? R is 12% compounded monthly, same interest rate. So R is 12% compounded monthly. So 12% means 0.12. Compounded monthly means we need to get monthly rate by divided by 12, right? Is equal to C 1 minus 1 plus R. R is 0.12 divided by 12 power minus T. Total 120 payments. Again for the 10 years. So again second annuity is again for 10 years, that is 120 payments. That means we want to receive C amount of cash flow for 120 periods or 120 months or 120 installments. So let us do this calculation first. So this one multiplied by 0.01. So this one will be, we will get 230038.6894. This is what we will get. So 230038.6894, and here we will get. So now let us calculate this one. So 1 minus bracket 1 plus, we will get a fraction 0.12 divided by 12 bracket close power minus 120. So we will get 0.697. Please check my previous video lectures, particularly video lecture series part 4. Please check my video lecture series part 4 to find out how you should calculate this using a scientific calculator. So C will be equal to what? So if you bring these one to left hand side, so it will go into the lower part of the fraction. So in the numerator we will have 230038.6894 divided by 0.697. This one is already in my calculator. So in the answer just now we have calculated it. So what we will do, 230038, we will press 230038.6894 divided by, we can just press answer button to get the more precise result. So 330038.6893 taka. That means if you deposit 100,000 taka at the end of every month for the next 10 years, in that case bank will give you 330,000 taka 330,038 taka at the end of every month for the following 10 years. But the insurance company offered you 350,000 taka. So it is clear, it's clear that insurance offer is much better. So it's clear. So here the insurance company offered us 350,000 taka for the following 10 years. But bank is, according to the interest rate bank is offering us, according to that, this C amount of cash flow is what? So bank is offering us 330,038 taka. Bank is offering us 330,038 taka at the end of every month, whereas insurance is saying that they will give us 350,000 taka at the end of every month for the following 10 years. But the bank will give us 330,038 taka for the following 10 years. So obviously insurance will pay us more. So it's clear insurance company will pay us more. So that means insurance offer is much better. So the insurance offer is much better. So we can, what the comment will be, what the insurance company will be much better. So bank will offer us, so bank will offer us bank will give us 330,000 taka, sorry, 330,038 taka 69 paisa at the end of every month, for the following 10 years, for the following 10 years. But insurance will give us, insurance company offered us 350,000 taka at the end of every month, for the following 10 years. So it is clear insurance offer is better. So thus it's clear that insurance offer is much better, insurance offer is better. So insurance company will pay us more than the bank. So insurance offer is better. Right, so let us solve question number 28. Let us solve question number 28. A company is planning to set up a new processing unit. Financial analyst is expecting to receive an average cash flow of 5 million taka every year for next 5 years. That means if the company set up this new processing plant, they are expecting to receive 5 million taka every year for next 5 years, and then 8 million taka every year for the following 6 years, and thereafter the project will have a terminal value of 80 million taka. That means terminal value means, after that, that means after total 11 years, that means after 11 years they will terminate the project, and when they will terminate the project, they will receive a total 80 million taka from selling the project or terminating the project, right? So the question is asking that if the company's cost of capital, that means cost of capital means the required return, that means if the required return from investment or required return from the project is 17%, in that case how much they should invest now, how much they should invest now. So let us put it on the diagram. So let us put it on the time diagram, right? So here this is the time diagram. Today is period 0. So question said that from this project we will get 5 million taka every year for next 5 years. So that means 5 million taka every year for next 5 years. So that means at the end of 1 year we will get 5 million taka. At the end of 2 years, we will also get 5 million taka. At the end of 3 years, we will also get 5 million taka. At the end of 4 years, we will also get 5 million taka. At the end of 5 years, we will also get 5 million taka. That means, so from the first 5 years, we will get 5 million taka at the end of every year, right? And then we will get 8 million taka every year from following 6 years. So we will get 8 million taka every year from following 6 years. So following 6 years means like from the 6th year we will get 8 million taka. So at the end of 7th year we will also get 8 million taka, and like that way up to 11 years. So this is the first 5 years. This is the first 5 years. First 5 years period. So first 5 years. So this is annuity 1. Let us consider that this is annuity 1. Annuity 1. So and then next 6 years. So following 6 years we will get 8 million taka every year. So following 6 years, that means total 11 years period. So following 6 years we will get 8 million taka at the end of each period. So following 6 years we will get 8 million taka at the end of each period. And then after this 11 years period, the project will be terminated. And when they will terminate the project, they will get 80 million taka from selling the machineries or maybe other things. So from selling the machineries, or from they may sell the business to second party. So that means when they will, after 11 years of running the project, they may sell the project. So by selling the project they will get 80 million taka terminal value, that is the final value. So 80 million taka, or they will also receive 80 million taka after 11 years. That means when they will terminate the project after 11 years, they will receive 80 million taka as a single cash flow, right? So the question is asking, if the required return from investment is 17%, in that case, that means that if the required return, cost of capital means required return. So if the required return from investment is 17%, in that case, how much they should invest now? That means how much they should invest now. That means we need to find out the equivalent amount of all these future cash flows. We need to find out the equivalent amount of all these future cash flows today, right? So that means we need to find out the present value of all these future cash flows, right? So what we can do, we have here, this one is annuity 1, all these cash flows are 5 million, and then this is annuity 2, annuity 2, because all these cash flows are 8 million, right? So but this one is a single cash flow. So this one is a single cash flow. So in that case, how we do it? So in that case, what do we need to do? What we need to do, first of all, so we need to proceed it like this direction. So we need to bring all the cash flows one by one to period 0. First of all, we will deal with this one. This is a single cash flow. This is a single cash flow. We will bring this cash flow from here to here. So that means we will go back 11 years period. So from this is the cash flow you will get after 11th years. So what we will do, we will move this cash flow from 11 to 0, right? So let's do it. So let us do it. So to do this one, what we need to do, we need to find out the total present value. So first of all, as I said before, first of all, we will deal with the 80 million. So this single cash flow. So as you already know, if you want to move this single cash flow, this is a single cash flow. If you want to go back, you need to find out the present value. So since we are going back, we need to find out the present value. So this is not annuity, this is a single cash flow. So that means, so we need to use this formula. So we need to use this formula. So since we are going behind, we will use the present value formula, but this is a single cash flow. In that case, we will use this formula, power minus T. So this is the cash flow that we are moving back to 0. So this 80 million will be the future value. This 80 million will be the future value. Right, so 80 million is the future value multiplied by 1 plus R. So 1 plus R power minus T. So 1 plus R is the cost of capital or required return, which is 0.17, which is 0.17, and we need to move 11 years from, this is the cash flow that we are getting at period 11. So from period 11 to 0, we want to move from period 11 to 0. That means power should be minus 11, right? Plus. So now let us calculate this one. First of all, we will calculate this one. So let us calculate this one. 80 multiplied by 1.17 power minus 11. So the value will be, so 80 into multiplied by 1.17 power minus 11. So we will get 14.2247 million taka. So this is what we will get. So that means the equivalent amount of 80 million, this 80 million, so equivalent amount of this 80 million taka at period 0 is equal to 14.2247 million taka. So that means this cash flow, we have already brought this cash flow to period 0. So that means we are done with this one. So we can ignore this one now. We are done with this one. Since we are done with this one, we can ignore it. Right. Now we will gonna deal with this cash flow. This annuity 2. We need to bring this cash flow to period 0. We need to bring this cash flow to period 0. But we cannot go directly to period 0. We cannot go directly to period 0. Remember. So this is the first cash flow of the annuity 2. This is the first cash flow of annuity 2 received at period 6. So this is the first cash flow of annuity 2 received at period 6. Remember, so since we want to go back, we will use present value formula. So we will use present value formula. But if you are using, this is annuity, there is no doubt. So we need to use the present value formula, which is C divided by R multiplied by 1 minus 1 plus R power minus T. So we will use this formula because we want to go back. But as I said before, we cannot go back directly. So the value that you will receive, when we use this formula, the present value that we will get, that value we will receive at period 5, not at period 0. So the value that we will calculate using the present value formula of annuity that value we will get at period 5, because this is the starting point. Sixth period is the starting cash flow. Sixth period is the starting cash flow for annuity 2. So the present value of annuity 2 will be received at period 5. At period 5. So first of all, let us calculate this one. So the formula is what? C divided by R. So C here for the annuity 2, C is 8 million, because we are getting 8 million cash flows at the end of each period here. So 8 million is the cash flow, and C divided by R. R means cost required return, which is 0.17. Bracket 1 minus 1 plus 0.17 power. So here how many cash flows are here? We have 6 cash flows. 6 years means 6 payments or 6 installments. So 6 years, that means 6 payments of $8 million each. So power will be minus 6. So let us calculate these one first. So let us calculate these one first. So we will calculate these one first. We will calculate these one first. So let's do it. 8 divided by 0.17 and then bracket 1 minus 1.17 power minus 6. Right. So the value we will get is 28.7134 million taka. So these value, so the present value of annuity 2, 28.7134 taka, will be received at period 5. So this value will be received at period 5. So this value, the present value, sorry. So the present value formula, so the value that we will get, the value we get will be received, that is this 7134 million. This value we will get at period 5. We will get at period 5. Right, but we cannot stay there, because our ultimate destination is period 0. So that means this is the value, this value 28 point, this present value of annuity 2 is received at period 5. So from period 5 to 0, we need to move from period 5 to 0. So now this is a single cash flow. Now this one is a single cash flow. So we are going behind, so we will use present value formula. So since we are going behind, we will use present value formula, but this is a single cash flow now. So the formula will be F into 1 plus R power minus T. So the formula will be power minus T. So formula will be this one. Right. So that means since this is now a single cash flow, since this one, the present value of annuity 2 received at the end of 5th period, this is the single cash flow now. This is the value, that is the present value of annuity 2 received at 5th period. So now we cannot stay at 5th period. We need to move back to 0. So now this is a single cash flow. We need to move this cash flow to period 0. So that means this is the future value. So this is the future value. That means we need to multiply this one. This is the future value now for us. We need to multiply this one with 1 plus R. R is 0.17 multiplied by, we are moving, this is the cash flow that we will get at period 5. So from 5 to 0, that means we need to move 5 periods behind. So we need to move 5 periods behind. So obviously here also we will write that one. So 1 plus 0.17 power minus 5, because this is the value we get from these one. So this is the second part, right? So that means let us calculate these one first. Let us calculate these one first. So 14.2247 plus, so let us calculate these one now. So 28.7134 multiplied by 1.17 power minus 5. So power minus 5, that means 13.0965. So that means what? This is the value of annuity 2. This is the value of annuity 2. This is the value of annuity 2 at period 0. So that means this is the value of annuity 2 at period 0. So what that means, these are this cash flow, this annuity 2 cash flows, we have first calculated the present value of annuity 2 at period 5, and we have calculated value of these annuity at period 0. So that means first of all we have jumped to period 5, and then we have also made another jump to period 0. So this is the final value of this cash flow. This is the final value of this cash flow at period 0. So that means we are done with this annuity 2. So we are done with this annuity 2. So we can now ignore this one. We have already brought all the values of these future cash flows to period 0. So we are done with this one. So since we are done with this one, we can now erase this one. So we can just ignore this one. We are done with this. Now we need to process, we need to bring this cash flow, at period 0. So again, this is annuity 1, because why annuity 1? All the cash flows are same. So we have multiple cash flow of 5 million taka each, right? So this is again, since we are moving behind, since we need to move back to 0, so we will use present value formula. So we will use present value formula, and multiple cash flows of equal amount there. So annuity, so that means we will use present value of annuity formula again. Sorry. Power minus t, right? So now again, so this is the starting point of the annuity 1. This is the starting cash flow, or the first cash flow of annuity 1. So if you apply this formula, if you apply this present value of annuity formula, the present value of annuity 1 will be received directly at period 0. We don't need to make any adjustment. It will be received directly one period behind, that is at period 0, right? Which means now we will deal with annuity 1. So in annuity 1, 5 million taka is the installment amount or payment amount. So 5 million is the C for annuity 1, and cost of capital or required return R is 0.17. 1 minus 1 plus 0.17 power. So we have here 5 cash flows, 5 years. That means we have here 5 cash flows are there. So 5 cash flows are there. So here we have 5 cash flows are there, right? So here we have 5 cash flows are there. So power will be minus 5, right? So now let us calculate this part. 5 divided by 0.17 bracket 1 minus 1.17 power minus 5. So that means we will get 15.9967. That means 15.9967 will be here. So this is the value of annuity 2 at period 0. This is the value of annuity 1 at period 0, and this is the value of the terminal value at period 0, right? So let us add all of these. So 13.0965 plus 14.2247. So if you add all of these, we will get what? 43.3179 million taka. This is the value we will get. that means if you round it, we can write 43.31 million taka. So that means if you invest, if the company invest 43.318 million taka today, if the company invest 43.318 million taka today, in that case the company will receive so if the company invest 43.318 million taka today, the company will receive 5 million taka every year for next 5 years, 8 million taka every year for the following 6 years, and thereafter they will receive a terminal value of 80 million taka from the project, which will be equivalent to 17% rate of return per year, which will be equivalent to 17% rate of return per year. Right. So now let us solve question number 29 from practice set 1. So you want to set up so what we have in this question, you want to set up a pension fund that would give 60,000 taka every 6 months for 20 years starting 10 years from now. Right. So 10 years from now, that means after 10 years you are planning to retire, if you are planning to go for retirement. So you want to set up a pension fund. You want to set up a pension fund that means after 10 years you after 10 years you are planning to go for retirement, and you want to set up a pension fund for that, so that you should get 60,000 taka at the end of every 6 months for following 20 years, for the following 20 years. Now question is asking how much should you deposit every quarter in the pension fund for next 10 years, for the next 10 years to receive the pension amount, right? So question is asking how much should you deposit at the end of every quarter in the pension fund for next 10 years to receive the pension amount. So question is saying APR means annual percentage rate on simple ordinary annuity. So simple ordinary annuity means simple annuity means payment interval should match with the compounding interval. So simple annuity means payment interval should match with the compounding interval, or other way, compounding interval should match with the payment interval. So when it says when you want to receive payment at the end of each 6 month period, so that means in that case compounding period should also be semi-annual or after every 6 months. When you want to pay at the end of every quarter, in that case interest rate should also be calculated. So interest should also be compounded on a quarterly basis. So that's what simple annuity means. That means the compounding interval should match with the payment interval. So annual percentage rate is 12%. Right. So I'm repeating the question again. You want to set up a pension fund that would give 60,000 taka every 6 months for 20 years. But this payment will start 10 years from now, which means, let me draw it in the diagram. Let me put it in the diagram. Let me put it in the time diagram. Right, so this is the time diagram. Let me show. This is the time diagram. Right, sorry. Today is period 0. Right, so after 10 years from now you will retire. So 10 years from now you will retire, right? And from that period you want to receive 60,000 taka at the end of each 6 months period up to for 20 years. That means here you will retire. This is your retirement period. So this is your retirement period. So this is your retirement period. This is your retirement period. So from here you want to get, so after your retirement period, at the end of every 6 months period, you want to get 60,000 taka. That's the first installment. So this is the second installment. So like that way, in 20 years, so after every 6 months you want to get 60,000 taka. After every 6 months you want to get 60,000 taka for 20 years, and these will start 10 years from now. So these will start from here. So these annuity will start from here. This is the starting point. So 10 years from now, that means this is the starting point, right? So after 10 years you want to get 60,000 taka at the end of each 6 month period for 20 years. So you want to get this 60,000 taka cash flow at the end of each 6 month period for 20 years. So that means each 6 month period means after 6 months you want to get 60,000. After 1 year you want to get another 60,000. So like that, that means in 1 year there will be 2 cash flow or 2 payments. So in 1 year you will receive 2 installment or 2 payments of 60,000 taka each. So in 20 years you will receive total 40 payments, 40 installments of 40 installments or payments of $60,000 each. So the last period will be here 60,000 taka, right? So these are the cash flow you want to receive from the pension fund. These are the cash flow you want to receive from the pension fund. So obviously if you want to receive this amount of cash flow from your pension fund, you must have a amount of savings at this period. So to receive this cash flow, to receive this 40 installments of 60,000 taka each, you must have a certain amount of savings at this period, right? So first of all we need to find out that one. That means after 10 years, so after these 10 years you must have a big amount of savings in the bank account, so that bank should give you 60,000 taka at the end of every 6 months, and like that way up to 20 years. That means total 40 installments of 60,000 taka each. So because of that, if you want to receive if you want to receive all these cash flows, you must have a amount of savings in the bank at this period, right? So that means you must have a savings at this period. So that's what we need to find out. So this is the starting cash flow of the annuity. This is annuity. Let us call this annuity 2. So that means to receive this cash flow, you must have a certain amount of savings at this period. So this is the starting cash flow of annuity 2. So since we want to find out we want to go one period behind, that means we will need to find out the present value of annuity. So that means we will apply present value of annuity formula to find out how much you should have at this period. So that means how much you should have in the bank account at the previous period. So that means since we are going behind, we will use present value formula, and this is annuity, so we will use present value of annuity formula. So this is the formula, right? So first of all, let us find out this one. That means how much you will need, how much you should have in the account after 10 years. So after 10 years, how much you should have in the bank account. To receive the pension amount, to receive the pension amount of 60,000 taka after each 6 month period, after each 6 month period, after each 6 months period for 20 years, we must have following amount of savings in the bank account after 10 years from now. 10 years from now. So sorry. Now, so what should we need? So that means to have the pension amount, of 60,000 taka each after 6 months, after every 6 months period for the following 20 years. That means total 40 installments. How much we will need after 10 years in the bank account? How much we will need in the bank account after 10 years? So that means we need to find out the present value of all these cash flows at after 10 years. So that means how we need to find out the present values of all these future cash flows at this period. So let us find it. So let us apply the present value of annuity formula, which is C divided by R, bracket 1 minus 1 plus R power minus T. So here C is the 60,000 taka cash flows. That's the installment amount. R required, so R is here. So remember, so here you are getting cash flows after, you want to get cash flows after each 6 month period, that is semi-annual period. So that means interest rate should be 12% compounded semi-annually. So for this period, interest rate should be 12% compounded semi-annually. For the annuity 2, interest rate should be 12% compounded semi-annually. Why? Because it is ordinary. It said that annuity is simple annuity. So simple annuity means payment interval is you are to receive payment after each 6 month period. That means semi-annual period. So obviously payment interval should match with the compounding interval. So compounding interval should also be semi-annually, 12% compounded semi-annually. So here the interest for the annuity 2, interest rate should be 12% compounded semi-annually. So 12% is the annual rate. Compounded semi-annually means we will divide it by 2 to find out the semi-annual rate. Then 1 minus 1 plus 0.12 divided by 2 power minus T. So here how many cash flows are there? Total 40 cash flows or 40 installments. In annuity 2 we have total 40 cash flows or 40 installments are there. So here we will have minus 40. Right, so let us find it. Let us do the calculation. So this is 60,000 divided by 0.12 divided by 2, that means 0.06. So 1 minus, here we will get 1.06 power minus 40. We could do it directly also. $60,000 divided by 0.06 bracket 1 minus 1.06 power minus 40. Bracket close. So 60,000 divided by 0.06, 1 minus 1.06 power minus 40. So the value will be 902 777 0.8123 taka. That means after 10 years you must have this amount of taka, this amount of savings in your bank account. So this is the amount you will need after 10 years in the bank account. So this is the amount you will need after 10 years. That means we will gonna need, that means after 10 years, sorry, so after 10 years we will need this amount in the bank. So after 10 years we will need this amount of savings in the bank account. So after 10 years we will need this amount of savings in the bank account. So now the question is asking, how much you should deposit every quarter in the pension fund for next 10 years to receive the pension amount. So now the question is asking how much should you deposit every quarter for next 10 years to receive the pension amount. So that means now the question is asking that how much you should save at the end of every quarter. How much you should save at the end of every quarter. So every quarter for next 10 years, which means how much you should save at the end of every quarter for next 10 years. So next 10 years means total in 1 year we have 4 quarters. In 1 year we have 4 quarters, that means total 40 installment of C amount of cash flows. So these will be 40. Last this one. So that means question is asking now how much you should save at the end of every quarter. That means we need to find out the value of C, right? That means how much you should save at the end of every quarter to save this amount of money after 10 years, to have this amount. So that means how much you should save at the end of every quarter so that you should have this amount of savings after 10 years. That will give you 60,000 taka at the end of each 6-month period as a pension for the following 20 years. That means total 40 payments. So that means we need this amount of savings after 10 years to have. That means to have this amount of savings after 10 years, how much you should save at the end of every quarter. So obviously this is the annuity 1. This is annuity 1. So for this annuity, so here we are saving C amount of cash flow after every quarter to receive this amount of money after 10 years. So this amount is the future value for this annuity. So this is the future value for this annuity. So future value for this annuity 1 we know. So future value of annuity 1 we know. So future value of annuity 1 is the, so future value of annuity 1 so future value of annuity 1 is this one, this amount 902,777.8123 taka, right? So we will use future value of annuity formula in that case, since that's the value we know. 1 plus r power t minus 1, that's the formula. So let us do cross multiplication. Fr is equal to C into 1 plus r power t minus 1, right? So now Fr, future value of annuity 1, this is the amount we need after 10 years. So this is the amount we want to save 10 years. So this is the amount that we will need after 10 years. So this is the amount we want to save, we want to get after 10 years. So that means this is the future value. multiplied by R. Now what will be the R? Since you want to save at the end of each quarter, so here for annuity 1, in the annuity 1 you want to save at the end of every quarter. So that means payment will be made quarterly. So interest rate will also be quarterly, compounded quarterly. So interest rate will also be compounded quarterly. So it will be, interest rate will be 12% compounded quarterly. It was before compounded for annuity 2, it was compounded semi-annually because the payment interval was semi-annual interval. But here the payment is made at the end of, so we are depositing at the end of every quarter. So interest rate should also be quarterly. So 12% quarterly. Right. So for annuity 1, payment interest rate is 12% compounded quarterly. So 12% is the annual rate. Quarterly means in 1 year we have 4 quarters, so we will divide it by 4. So C into 1 plus 0.12 divided by 4 power T. How many cash flows are there? In annuity 1, 40 cash, in annuity 1 we have 40 cash flows. So in annuity 1 we have 10 years, that means every year we will have total 4 quarters, that means 40 installments. So 40 cash flows are there. So annuity 1 we have 40 cash flows are there. So power T means power will be 40 minus 1. So first of all let us calculate this one. So if you, so 12% divided by 4, that means 3%, that is 0.03. So which is 27083.3343. So this value was already in my calculator. I just multiplied by 0.03. That's why I got this value. You may get slight different value. Don't worry. Right. C multiplied by. Let us calculate this one now. So 1.03 power 40. 1.03 power 40 minus 1. So that means minus 1, which is 2.26203. Right. So in that case C will be equal to what? 27083.3343 divided by 2.26203. Right, so 27083.3343 bhag answer button if you press, so you will get 11972.9804 taka. Right, so that means 11,972. So that means if you save 11,972 taka 98 paisa at the end of every quarter up to 10 years, in that case after your retirement period you will receive 60,000 taka at the end of each 6-month period for 20 years. Right, so that's the answer. Now I will show you, as I have told you that in my last lecture of time value of money video lecture series, I will show you derivation of perpetuity formula. So let me show you derivation of perpetuity formula. Sorry, not perpetuity, derivation of annuity formula. Derivation of perpetuity formula I have shown you before. So now I will show you derivation of annuity formula, as I have promised to you before. I told you that I will show you the derivation of annuity formula at my last lecture, right? So to understand the, first of all, you know that this is the formula. Annuity formula, annuity, present value of annuity formula is C divided by R, 1 minus 1 plus R power minus T. So we can also write it like C by R multiplied by 1, that means C by R, minus, again we can multiply C by R with these one. So C by R multiplied by 1 plus R power minus T, right? So I have told you that this one means C by R means perpetuity. So that means present value of annuity means present value of perpetuity 1 minus present value of perpetuity 2. So present value of perpetuity 2 starts at period T. Right? So now how it looks, how it is like that. So let me show you. So you can understand better with a time diagram. Here T is equal to 0. So period 1 you will receive C amount of cash flow, period 2 C amount of cash flow, period 3 C amount of cash flow, and like that way up to infinite period. So this is perpetuity 1. So that means this is perpetuity 1. So this is T period. After T period also you will get C amount of cash flow. After T plus 1 period also you will get C amount of cash flow. After T plus 2 period also you will get so let me write it in small letter. So after T period you will get C amount of cash flow. After T plus 1 also you will get C cash flow. After T plus 2 period also you will get C amount of cash flow, and like that way up to infinite period. So this is perpetuity 1. Perpetuity 1 starts at period 0. This is perpetuity 1. So obviously the present value of this perpetuity is so the present value of this perpetuity is C divided by R. We already know, right? Now another perpetuity that starts from this period at T period. So another perpetuity that will start at T period. So that means the cash flow that you will get, the first cash flow you will get at T plus 1 period. So second cash flow you will get at T plus 2 period, and like that way up to infinite period, So this is perpetuity 2. This is perpetuity 2, right? This is perpetuity 2. So obviously the present value of perpetuity is always C divided by R. So value of perpetuity is always C divided by R. But if you apply this formula for this perpetuity, so this C by R value you will get not at period 0, because this perpetuity haven't started from period 0. This perpetuity have started from this period. This perpetuity have started from this period. So this is the period where this perpetuity have started. So this C by R value, present value of the perpetuity. So present value of this perpetuity 2, that means the value of this perpetuity 2, that means the present value. If you apply this formula for the perpetuity 2, this C by R value you will get at period T. This is the period T. You will get at period T, right? Right. So now if you deduct all these cash flows from all these cash flows, that means if you deduct cash flows of perpetuity 1 minus cash flows of perpetuity 2, you will be left with this cash flow. That means you will have period 1 C amount of cash flow, period 2 C amount of cash flow, period 3 C amount of cash flow, and up to T period, because these are the cash flow for perpetuity 2. The cash flow has started from T plus 1 period, and then it moves on up to infinite period. So for perpetuity 2, cash flow has started from T plus 1 period, and this is the cash flows of perpetuity 2. So that means if you deduct these cash flows, from these cash flows, in that case you will have only these amount of cash flows left. That means if you deduct cash flows of perpetuity 1 minus cash flows of perpetuity 2, that means in that case you will get annuity. So this is annuity, because here in this here cash flows are only limited to T period. Cash flows are same amount of cash flow at equal interval period are limited to only fixed period. That means this is annuity. This is annuity. This is annuity. So how we get annuity? Annuity means cash flows of perpetuity 1, cash flows of perpetuity 1 minus cash flows of perpetuity 2. Cash flows of perpetuity 2. So obviously if you want to find out the present value of annuity, you need to know present value of perpetuity 1 minus present value of perpetuity 2. Right. So present value of perpetuity 1 we already know. Perpetuity 1 has, so present value of perpetuity 1 we all know. So this perpetuity 1 has started from period 0. So that means the value is, present value of perpetuity formula is C divided by R. So present value of this perpetuity is what? P is equal to C divided by R. That we already know. So present value of perpetuity 1 is equal to C divided by R minus, now the present value of perpetuity 2. Now the present value perpetuity 2, as I have told you before, perpetuity 2 has started, the cash flows of perpetuity 2 has started from T plus 1 period. That means perpetuity 2 has started from T period, and the cash flows have started from T plus 1 period. Right. So obviously the value, that means the perpetuity formula for the perpetuity present value formula is C divided by R, but this present value you will receive, this C by R present value of perpetuity 2 you will receive at T period. You will receive this value at T period, not at period 0. So that means you need to you need to come back to this period, sorry, you need to get this value at period 0, at period 0. So that means you need to move this cash flow back to period 0. That means this is now a single cash flow. This is now a single cash flow. You need to move this cash flow to period 0. That means we need to move it back to period 0, right? So we are moving t periods behind. So this is a single cash flow since we are moving back. So now we will apply this formula. So if you are, since you are moving back, you will apply present value formula. But since this one is a single cash flow now, C by R now is a single cash flow. So that means we will apply this formula. This is not annuity anymore. We will apply this formula. So here this is the cash flow that we need to move it back to period 0. So that means here this will be, future value will be C by R multiplied by 1 plus R power minus T. So that means present value of perpetuity 2 at period 0. So present value of perpetuity 2, sorry. So present value of perpetuity 2 at period 0. So present value of perpetuity 2 at period 0 is C divided by R multiplied by 1 plus R power minus T. So if you take C by R common, you will have 1 minus 1 plus R power minus T. So this is the present value of annuity formula. So this is the, that's how we got present value of annuity formula. Right. Now what will be the future value of annuity? So future value of annuity will be what? Future value of annuity formula. Future value of annuity formula. So this is now present value of annuity, right? This is now present value of annuity. This is a single cash flow now. So future value of annuity. So since this one is a single cash flow now, because if you calculate this one, you will get a single cash flow. If you calculate this one now, you will get a single cash flow, right? So that means now if you want to find out the future value of this amount, single cash flow, so we already know future value of a single amount is P, F is equal to P into 1 plus R power T. So that means if you want to find out the future value of this single cash flow, what do you need to do? You need to multiply this one with 1 plus R power T, right? So that's what we will get. So here first of all we can write this one as C by R minus C by R into 1 plus R power minus T, and then outside the bracket we have 1 plus R power T. Now we can multiply this one with this one. So let's do it. So C by R multiplied by this one is equal to C by R into 1 plus R power T minus, then we will multiply this one and this one, right? So that means C by R into 1 plus R power minus T multiplied by 1 plus R power T. Minus, so C by R. So here as you can see, here also base 1 plus R, here also base 1 plus R. So power will be added together. So that means we will have 1 plus R power T minus T plus T, power minus T plus T. So that means this T and this T and this T will cancel each other out. So, oops, sorry. So this T and this T will cancel each other out. So we will be left with C by R into 1 plus R power T minus C divided by R, right? Now 1 plus R power 0. So t minus t is equal to 0. So power 0 means if you get a power 0 over any base. So if you get a power 0 over any base, you will get 1. So that means from these one we will get only 1. So from these one we will get only 1. So that means multiplied by 1. So multiplied by 1, if you multiply these one by 1, you will get C by R only. So that means that's the future value of annuity. So that's the future value of annuity. So future value of annuity. So if you take C common here, C by R common here, we will be left with 1 plus R power t minus 1. So this is in this way we can get the annuity formula, present value of annuity formula and future value of annuity formula also, right? So that's the end of time value of money lecture series. So that's the end of time value of money lecture series.